Hey guys, welcome back. We're going to be looking at naming fractions using an area model. This should all be review from last year. So let's just have a look at these two circles. I have one that is divided into 4 pieces, and I have one that's divided into 5 pieces. So my question for you is, do I write both as a fraction of 1/4, or do I write this one as 1/5? And I just want you to take a time to just to think about that and what you know about fractions. So if I'm reviewing what I know about fractions, I know that if something is a fraction, it needs to be, the parts need to be equal. So if I'm comparing these two fractions, this whole section here is equal to these sections here. If I wanted to make it equal the other way, I would have to draw more lines in there to make it equal. But I can say that this is 1/4. So 1 out of 4 sections is shaded. If I'm looking at this fraction, this up here tells us the shaded part, okay? And this is called the numerator. And this down here is called the denominator. And it is how many equal parts there are that we're dealing with. Okay, so if we were looking at these here, and I asked you which shapes are shaded so that half of them are shaded. Well, we can go and we can look at A, and if I had drawn this correctly, so it's cut in half, and half of it is shaded. So this would definitely be 1/2. If we're looking at B, it's not cut in half. Both sides are not equal, so it would not be half. C, same thing, not cut in half. I can't fold it in half and have both sides be the same. And D, I can fold this triangle in half, so that would be half. E, same thing. It's not half of the shape. F and G are the same as well. If I'm asking which shape would be 1/4, okay, so I know that these ones are half, so I won't deal with those. If I look at B, it looks like it's shaded. 1/4 of it is unshaded, but again, if I drew in the other lines, these would not be equal. They're not equal parts, therefore this is not a fraction. Same as if I look at C. If I drew in the more lines and divided it up so that there were 4 parts, they're not equal parts, so therefore this is not 1/4. If I'm looking at E, and I drew this oval perfectly, this shape here would be the same size as the other shape. So 1 out of 4, 1/4 are shaded. If I look at F, these again are not equal parts, so it can't be described as a fraction. And this one here, all parts are equal, but if I look at it, there's 1, 2, 3, 4, 5 parts, so this would actually be 1/5. So these are how I actually like to do fractions. These are called fraction strips. They're much easier to draw. You can use a ruler and you can make them perfect, so they're easier to compare. And so if I'm looking at this first one is actually 50 centimeters. And this first 20 centimeters of the 50 centimeters is shaded. So usually I would ask you, what fraction of this fraction strip is shaded. So what I've done is I've measured it out by each square being 5 centimeters. So I have that's 10, 20, 30, 40, and then obviously 50 at the end here. So I have it evenly divided, and I can do that by measuring with a ruler as well to make sure that I'm dividing it evenly. And so I have 1, 2, 3, 4, 5 equal parts. So the denominator would be how many equal parts I have in total, and the numerator would be how many parts are shaded. Okay, so now I have 10 centimeters and I have a 60 centimeter strip. So I'm going to divide this into equal parts. I'd be using a ruler, and so I have 1, 2, 3, 4, 5, 6 equal parts. So this would be, the denominator would be 6, and the numerator is 1 shaded part. And again, with this strip, I'm going to divide it into equal parts. This is an 80 centimeter strip. Okay, 50 centimeters of that is shaded. So I have 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So the denominator would be 8 and the numerator would be 5. Now, if I'm looking at these boxes are all the same size. I made sure I measured them out properly. So if I'm looking at just the top two with the red, and I was going to share this piece of paper or this cake or this, whatever you want to call it, with 4 friends, I want to make sure everybody gets the same amount. And I folded it like this. What my question is this square equal to that? Is it the same amount of area that is being covered? Okay. So if I'm looking at this square, these squares are all equal sizes. The first one, all equal sizes. This would be 1/4. Now, would the fraction be the same for the second one? If I measured all of these out completely equally, then I still have 4 equal pieces, and someone gets one of those. So these would be the same. They would be equivalent to each other. Same as the next. I have a square. I've cut it in half, but I've done it diagonally, and then I've cut the other one in half vertically. Okay? So my question would be, is it the same fraction? Are these fractions the same? Are they equivalent? Are they equal? So they may not have the same shape that's shaded, but they do have the same amount shaded. So there's 2 equal parts here, 1 and 2, and there's 1 part shaded, and they're the same size as the other ones. So I have 1 out of 2 shaded. So they might not be the same shape, but they are the same amount that's shaded because they're 2 identical squares. If I joined these 2 squares together and I made a rectangle, and then I gave my friend this one piece, are these 4 parts equal? Well, I know that from here to here is the same measurement as from here to here. So these parts of the square are equal, and they're divided up into different shapes, but they're the same amount. This is half of this square, and this would be half of this square. So there's 4 equal parts, and 1 part is shaded. So what I'm going to get you to do is I'm going to get you to go on and complete the next exercise that's in the PowerPoint. If you are struggling with this, because this is just a review, send me an email and I'll send you some stuff that we can practice.